Hello everyone and welcome back to another Universe Sandbox2 video, and today we're going to actually be doing something a little interesting, because something I've actually been wondering, and that is, what if Alpha Centauri, so this star right about somewhere here, what if this star was our sun? Because if you didn't know, Alpha Centauri is pretty much exactly the same as our sun in most aspects. It's slightly got a little more mass, it's slightly bigger, and it's a yellow main sequence star. So as you can see here, it's pretty much almost the same, but I think its luminosity is slightly different, so we're going to actually place it right in the middle here, and we're going to see if it's going to make any difference whatsoever. So we're going to delete the sun. So this guy, if we check its luminosity, it's 1.48 suns, so it is slightly brighter. So we're going to see if this has any effect on the planets in our solar system, and if it doesn't much and it's quite short, I'll also do it with Proxima Centauri just to see how cold everything would get, because obviously this is a lot smaller. And then Alpha Centauri B, I mean, we could try it, but it's sort of in the middle, so I don't know. But yeah, we'll just see how it goes. So, Alpha Centauri A, so we're going to make everything auto-orbit around it, because we don't want the orbit or everything just flying off in random directions. So, this is pretty much as accurate as we can get it without taking forever to do it. So, yeah, Earth is pretty much in the right spot. So, yeah. Let's go and hit play here. We're going to start seeing if this is going to have any effects on the planet. So Venus is the main thing I want to look for here, because Venus is probably going to get affected the most by the slightly brighter star. So we're going to go ahead and hit play, and it is warming up as we can see here. So has made a slight difference, because if we go to Venus now, we can actually start seeing its surface. That's just how hot it is. So that's made quite a big effect on Venus there. So that's pretty interesting. Right, let's check out Earth and Mars as well. So Earth's all the way down here for some reason, no idea why. So Earth, okay, it's cool, or it's heating up very slowly. So I'll put climate mode on. Okay, it's already on. So how well are the polar caps doing up here? So okay, the polar caps still looking relatively normal. Okay, they're looking fine. But what's going to happen if we start to speed this up more? So is it going to get too hot? I don't think it will get to evaporation point, because this star simply just isn't bright enough for this. But yeah, we're going to see if anything's going to happen. So 30 degrees, so it's getting very hot now, because yeah, trust me, if I was to live at 30 degrees permanently, I would hate it. That's why I like England. It's just nice and cool here. Nothing too hot, not really too cold, but I don't mind the cold as much. But when I was in Florida earlier this year, when I was checking out like the Kennedy Space Center and stuff, it was hot here. I could not live there. It is just so hot. Or anywhere in the equator area, so like the south of North America here, north of South America, Africa, probably the southern Europe, like Spain, Portugal, and Australia as well. I just couldn't live in these places, and probably Hawaii, since that's near the equator of Earth as well. I guess maybe India here, some of these islands, and then yeah, just Africa and stuff. Yeah, I couldn't live there. It's just too hot. That's why I just love good old England over here, nice and cool. But 37 degrees. See, yeah, that would if this is the average temperature of the entire planet, then that means that other places will be even hotter than this. So yeah, tell me, could you guys survive permanently that temperature? Even imagine how hot that would be at night time if it was always like that. It would just be horrible. Damn. Yeah, I just want to live in the south now. But look, even the south has melted. Look, if we look at it now, I know it's not really too much an effect, but in an Earth sort of world, if we just focus on Earth, that is a massive change. Because look, all of the ice is melted. Look, Antarctica is now showing its true landmass underneath all the ice. Because if you didn't know, bit of geography for you, underneath all the snow and ice on Antarctica is actually solid land, as we can see here. Like, this is proper land. This isn't ice. This is rock. But if you go to the North Pole, if you was to melt all of this, as you can see, it's just ocean. So there is no landmass up here. It's just frozen ice, which makes you think there's land. But there is actually no land, as we can see. Greenland is the highest country here, but there's no land in the absolute North Pole of Earth. But in the south there is land, because Antarctica is its own continent. That's why there's no North continent, because there is nothing there. So yeah, there's an interesting fact for you if you didn't know that. But yeah, let's get back to this. So 37 degrees. Now, can it break the 40 mark? That's what I want to know. 35. We're still increasing very slowly. So okay, it has hit 40. So yeah, at this point in time, if I was living here, I'd be suffering. Like the heat here. Because if this is, like I said, if this is an average surface temperature, yeah, surface temperature of the body. If this is an average, then damn, the equator temperatures, these must be going up to like 50. Maybe the temperatures up here are a little colder than that. Maybe, but yeah, if the whole planet was above 40 degrees, damn, that would not be fun. You just get dehydrated so quick, and it would not be a nice experience. So yeah, tell me, could you guys survive at 44 degrees Celsius every day, no matter what time of the year? So, yeah, could you survive 44 degrees? I'll probably leave a comment in the comments saying if you do it, because I certainly couldn't. So, yeah, there's that. But next up, I want to check Mars, because even though this thing, or this star here, is only 10% brighter than... Oh, no, it's not. It's about 48% brighter, I believe. So 1.48 suns. So just a little bit brighter. But even, that is a massive effect on Earth, because 44 degrees, it was originally 20 when we had the sun. So that has made a massive effect, even though it still looks the same. But with all the ice melting and stuff, that has made quite a big effect here. So if you want a good look at Earth, there you go. So if we just go to the south again. Oh, some of the ice has came back, actually, interestingly. If we turn that off, okay, that doesn't do anything. Yeah, the ice is still there, but in the north, there is no ice in the North Pole at all. So, yeah, the North Pole, the polar bears, I'm sorry, but yeah, they probably wouldn't be surviving right now, which isn't good. So, who we got next? So, yeah, I want to check out on Mars. How hot is Mars? Is it colonizable? So, minus 27. So, Mars is still too cold. We could colonize it, but that's not what we're doing for this video. But yeah, Mars is too cold still, minus 27. So, the coldest temperature on Earth, I believe, is colder than that. So, in theory, we could live here, but it would still be very not good with the harsh conditions of, like, the Martian weather and just the way Mars is. So, yeah, Mars is out of the question. And then the outer planets, they'll pretty much be the same. But one thing I do want to check out is how much light these dwarf planets are receiving. So, Pluto. I want to go to Pluto first. So, where's Pluto at? So, here's Pluto. How bright is it here? Is it receiving any more light than normal? Okay, it's still very dark and gloomy here. We'll check out on Sedna as well. I'm guessing it's... Yeah, Sedna's going to be pretty dark as well. So, Sedna, you are complete darkness. So, let's put you at your closest point to the sun. Yeah, Sedna's in darkness. So, Alpha Centauri isn't bright enough to light up Sedna. So, that's pretty good. Okay, Saturn, how are you? You good? Minus 178. So, yeah, still very cold here. So yeah, the outer solar system is still out of bounds. The sun, or this planet, or sun I should say, slightly hotter than our sun. It looks like it's 6 G years, so 6 galactic years. So that's 6,000. So that's billion years, 6 billion years old. How's Mercury doing? How are you? Okay, 1/6. So Mercury hasn't really changed, but because it doesn't really have an atmosphere, it doesn't really get too much greenhouse effect here. So yeah, there's that. So that is pretty interesting for Earth. So it's not even similar to itself anymore. Like Earth similarity, it should be 1.0, but now it's only 93%. So I'm assuming it's meant to be 1.0, but it still has a high life likelihood. But if we look there, the life likelihood is going down. Look, can you see that? Look, 94.7.6. So look at that. So oh no, it's just changing actually. It's just slightly changing, going up and down. Okay, forget that. It's not really doing anything. But wait, is it 50 degrees now? Damn. 56 degrees. Wow, that is... Yeah, I couldn't live here. 60 degrees. Damn. Oh, God. How's the south doing now? Surely there's no ice here anymore. Okay, it's still there, but that's definitely not going to last. 60 degrees. No, why is it suddenly just heating up like this? I guess we need to make time pass more, but... Okay, okay, it's all spazzing out. Why is it... It was at 60, then it's at 40 there. What if we turn off climate? Does that do anything? Okay, that doesn't really do anything. So... Yeah, but it did hit 60 there, so that is not good. Yeah, I would not like to live there. That's double the heat of how much... if I can't survive 30, 60 degrees, damn, that would just be unbearable. So, yeah, there you go. So, next up, we're going to try it with... Let's try it with Proxima Centauri. So, let's see how cold everything will get. So, even Venus could get pretty cold here. So, we'll put Proxima Centauri right in the middle here. So, let's place it there. Delete Alpha Centauri A. And we can then go and do auto orbit. So let's see what we got next. And as we can see, because this star has got such low mass, it's not really the orbits went all with. And now it's in a binary orbit with Jupiter because it's just so low in mass. So I only got 129 Jupiters to start, and it's only 0.002. So less than 2% or less than 1% overall. I think that's 0.2% luminosity of the sun. So very, very dim here. So now let's speed up time. Let's see how the planets cope with this. So even Mercury could get pretty cold here. So, oh my God, Mercury's become cold. Wow, okay. Wow, look how dark it is here. Mercury's usually very, very bright, but if we look from the surface of Mercury, it's going to have a look at our sun. Or the sun, I should say, since it is pretty much the sun. So, that's not very big. That's probably about the size the sun is from Jupiter. So, that's just how small this star actually is. So, remember, that star's only a little bit bigger than Jupiter there. So, that's not good. But Mercury... Minus 181 degrees Celsius. Damn. That's pretty crazy. Alright, so Venus. Minus 104. So even the hottest planet in the solar system is now cold. Or it's below 0 degrees. So that's not good. Okay, Earth. Sorry. Oh, well, the polar bears are going to get revenge. Now it's, okay, now it's getting too cold. So minus 87. So now I mentioned about being too hot. Now I'll be too cold. Because that's colder than Mars normally is with the sun. So the whole thing is just frozen snowball, as we can see here. So yeah, that's not good. Next up we have got Mars. So minus 222, and then the gas giants minus 198. So even Jupiter's hotter than Mars is. Uranus 213, 208, minus 208. Saturn minus 200. Where's Neptune? 223. Uranus should be colder than that. It's meant to be the coldest planet in the solar system. Okay, that's weird. Yeah, if you didn't know, I believe Uranus is meant to be colder than Neptune. So I think it reflects more light, actually. So yeah, there's that. So as you can see from Proxima Centauri being the sun, not much would really be going on in the system. All the life would die on Earth, because I don't think any life would be able to survive such cold temperatures as this. So even like things which are adapted to the cold, say like penguins, seals, all the stuff that lives in the south and north, polar bears, they probably wouldn't survive this. Because if you think about it, if you didn't know, you know how penguins huddle up to like share their warmth, like in packs in the South Pole. I believe that's because they're cold. But if the Earth was this cold, even the penguins probably wouldn't survive, even though they're adapted to the colder temperatures. Even if they huddled together, I don't think their body heat, sharing all their body heat, would be enough to keep them alive. Am I right there? I don't really know much about like the animals, but I'm assuming that's what would happen. Even huddling together, that wouldn't save them. They'd still get too cold and die, which is sad. Poor penguins, but yeah, there we go. So there's poor Earth. So now we're going to put Alpha Centauri B, I think. I've never done this one, actually. I never really used this star, so okay, there's all that. So Alpha Centauri B. So I don't actually know the stats for this star, so this could be interesting. So yeah, last star of the day. Let's put it right there. So I believe our sun is actually bigger than this. So yeah, this is a orange dwarf star. Cause if the sun is a yellow dwarf, this is orange dwarf. I believe it has less mass. It's colder, and its luminosity is only half of the sun. So we're going to see how much of an effect that will have on the solar system here. So we're going to hit play. See our orbits. Okay, so here we go. So Mercury, let's check out how you're doing. So Mercury should warm up into the positive temperatures again. Yeah, as we can see here, it's warming up, which is good. So let's see how you're doing. Okay, it's going up to 73 degrees. So still, it's not too hot. That's pretty much, Earth was almost this hot earlier with Alpha Centauri A. And Mercury's a lot closer. So yeah, this star's definitely a lot less brighter. Alpha Centauri A is almost 3 times brighter than this, actually. Since this is only half of the sun. And Alpha Centauri was almost about 50% bigger than the sun. So yeah, this is about 3 times brighter than that Alpha Centauri A was. So Venus, where are you? Actually, where are we? Okay, Mercury is 70 degrees. Venus is 300. So Venus is completely hot again. Earth minus 104. No way. Like if we put it to 0, does it reset? Okay, it still gets colder again. Okay, so with this star, Earth wouldn't work, as we can see here. So poor Earth, man. We're lucky we have our sun. The sun is just perfect for us. Because even with a sun a little brighter or a little too cold, it makes us too hot or too cold. So yeah, this is a temperature penguins would survive in normally. Because I'm pretty sure Antarctica is about always below minus 16 or something. I don't know the temperature, but yeah, I'm pretty sure it's always cold. So yeah, penguins and stuff would survive here. Us humans, yeah. The United Kingdom's not even visible anymore. It's all part of this giant continent connecting America, Europe, Atlantic Ocean, Asia, Russia, all of this stuff here. And then I'm guessing there's a giant sheet of ice in the south as well. Yeah, there is. So Antarctica is connected with South America, almost connecting with Australia. It's connected with New Zealand there. Okay, not touching Africa yet, but is it going to get any colder to make, or is it a whole world going to become one supercontinent again? So let's continue speeding this up and let's see what's going on. So yeah, it's still getting cold, and yeah, the whole planet is now just one big supercontinent. So there's no oceans anywhere. It's all frozen. Damn. So that's not good. So there's all our countries. So it's all connected together. So it's all one giant landmass. So yeah, poor Earth. So we couldn't survive around Alpha Centauri B there. So that's not good. So there's its zone. That's its zone there. Mars, how are you? Wait, Mars. Let me see. Wait, is that no? Where's Mars? No, Mars is that one. minus 85, so it's colder here than normal as well. And then the gas giants, well, they're always cold, but if you want a quick look, Jupiter minus 178, Saturn is minus 200, so that's colder than usual. Uranus 221, and Neptune is 230, so a little colder than Uranus there. So yeah, there we go, guys. So hopefully you've enjoyed this video. Yeah, because that's pretty interesting actually. So yeah, hopefully you enjoyed the video of me putting the Alpha Centauri star system stars into our solar system. So it seems to make a big effect. I know they're not the craziest of stars, like the big guys over here, like the bigger stars, like stuff like this, the big kings, the brightest stars, the biggest stars. Yeah, it's nothing crazy like that, but even smaller stars like this, just with slightly different luminosity, still have a very big effect on the inner three planets, so Mercury, Venus and Earth. All their temperatures changed a lot, as we did change the stars from A, B and then Proxima. So that's pretty interesting. But yeah, we'll quickly end this off as well. So let's actually check their luminosities out compared to each other. So yeah, there we go. So yeah, guys, if you all enjoyed this video, make sure to hit that like button, hit the like button, subscribe for more. Helps on the journey to 1,200 subscribers. Damn, I'm so bad at outros, I'm sorry, but yeah, helps on the journey to 1,200 subscribers because we are growing so fast right now. It is actually insane. Yeah, can't thank everyone enough. You're awesome. Got any ideas for a video? Feel free to leave a comment down below. I'll hopefully get around to doing it at some point. And I know I can't do everyone's idea because some of them, I think maybe it's not they're bad. It's just they're not long enough to make a video on, because some of them I'd literally take me a minute to make a video on. So yeah, it wouldn't be a very long video, and I know you guys do like longer stuff. So yeah, there we go. There is the habitable zones of all the stars. So Proxima Centauri is very, very small. Then we've got Alpha Centauri B, which is about a half or a little, yeah, more of Alpha Centauri A. So Alpha Centauri A is definitely the brightest of the Alpha Centauri system. Then if you want a quick size comparison as well, these guys, A, B and Proxima. So it's quite a different size difference there. So if you want a better look, we'll quickly turn off glows. So yeah, there you go. There is the Alpha Centauri stars. So yeah, look at that. So looking good. So yeah, make sure you guys all have a good day as well, and I'll see you in the next video. Goodbye. Damn, I'm so bad about outros, I'm sorry, but yeah, laters. I think its luminosity is slightly different, so we're going to actually place it right in the middle here, and we're going to see if it's going to make any difference whatsoever. So we're going to delete the sun. So this guy, if we check its luminosity, it's 1.48 suns, so it is slightly brighter. So we're going to see if this has any effect on the planets in our solar system, and if it doesn't much and it's quite short, I'll also do it with Proxima Centauri just to see how cold everything would get, because obviously this is a lot smaller. And then Alpha Centauri B, I mean, we could try it, but it's sort of in the middle, so I don't know. But yeah, we'll just see how it goes. So Alpha Centauri A, so we're going to make everything auto-orbit around it, because we don't want the orbit or everything just flying off random directions. So this is pretty much as accurate as we're heating up very slowly. So I'll put climate mode on. Okay, it's already on. So how well are the polar caps doing up here? So okay, the polar caps still looking relatively normal. Okay, they're looking fine. But what's going to happen if we start to speed this up more? So is it going to get too hot? I don't think it will get to evaporation point, because this star simply just isn't bright enough for this. But yeah, we're going to see if anything's going to happen. So 30 degrees, so it's getting very hot now, because yeah, trust me, if I was to live at 30 degrees permanently, I would hate it. That's why I like England. It's just nice and cool here. Nothing too hot, not really too cold, but I don't mind the cold as much. But when I was in Florida earlier this year, when I was checking out like the Kennedy Space Center and stuff, it was hot here. I could not live there. It is just so hot. Or anywhere in the equator area, so like the south of North America here, the north of South America, Africa, probably the southern Europe, like Spain, Portugal, and Australia as well. I just couldn't live in these places, and probably Hawaii, since that's near the equator of Earth as well. I guess maybe India here, some of these islands, and then yeah, just Africa and stuff. Yeah, I couldn't live there. It's just too hot. That's why I just love good old England over here, nice and cool. But 37 degrees. See, yeah, that would if this is the average temperature of the entire planet, then that means that other places will be even hotter than this. So yeah, tell me, could you guys survive? Hello everyone, and welcome back to another Universe Sandbox2 video, and today we're going to actually be doing something a little interesting, because something I've actually been wondering, and that is, what if Alpha Centauri, so this star right about somewhere here, yeah, here, what if this star was our sun? Because if you didn't know, Alpha Centauri is pretty much exactly the same as our sun in most aspects. It's slightly got a little more mass, it's slightly bigger, and it's a yellow main sequence star. So as you can see here, it's pretty much almost the same, but I think you can get it without taking forever to do it. So yeah, Earth is pretty much in the right spot. So yeah, let's go and hit play here. We're going to start seeing if this is going to have any effects on the planet. So Venus is the main thing I want to look for here, because Venus is probably going to get affected the most by the slightly brighter star. So we're going to go ahead and hit play, and it is warming up as we can see here. So has made a slight difference. If we go to Venus now, we can actually start seeing its surface. That's just how hot it is. So that's made quite a big effect on Venus there. So that's pretty interesting. Right, let's check out Earth and Mars as well. So Earth's all the way down here for some reason. No idea why. So Earth. Okay, it's cool. Oh, it's